hyperbola, general and standard equations. So last time I defined to you the set of points that we call the hyperbola, and I also showed to you the standard equations for a hyperbola with center hk. So when our center is hk and the transverse axis is horizontal, this is our standard equation. C is greater than A, and C squared is equal to A squared plus B squared. So HK is the center. The value of A will give us the distance of the vertices from the center. Okay? So the vertices will define to us the line segment, which is the transverse axis. C squared is equal to A squared plus B squared. And the value of C, okay, what information can we get from C? It's the focus. It's the distance of the focus from the center. So this is how your parabola might look like, okay? So the transverse axis, okay, so this is the transverse axis, okay? The line segment that connects the two vertices. When our transverse axis is vertical, this is our standard equation. Okay, so let us compare the two standard equations. When we are looking at the standard equation, how can we tell if the transverse axis is vertical or horizontal? Well, it's something like this. Okay, so the operations between the two terms is subtraction. When the term that comes after subtraction is y, such as this one, then you are looking at the standard equation of a hyperbola whose transverse axis is horizontal. When the term that appears after subtraction is x or x squared, then you are looking at an equation that defines a hyperbola whose transverse axis is vertical. Okay, and so your hyperbola might look something like this. So a squared, look at a squared again. Okay, so we must pay attention which is a squared and which is b squared. So b squared would be the denominator that appears after subtraction. This is the general equation of a hyperbola. It is equal to a times x squared plus c times y squared plus d times x plus e times y plus f is equal to 0. Here, a times c is negative. It's less than 0. And of course, because the operations that separates these two terms is subtraction. And so, if you were now to write this in general form, the coefficients of x squared and y squared, they will have different signs. When the equation of our hyperbola is in general form, okay, it's not too helpful really because we cannot tell right away what is the orientation of your transverse axis. Is your hyperbola standing up or is it lying down, or is the transverse axis horizontal? And you also cannot tell right away what is the center. It does not show important information that we can see when the equation is in standard form. So you know what's going to happen next, okay? And we had done many of this before. We are given an equation of a hyperbola in general form. For example, this one. So how can we tell what is the center, what is the principal axis, and what are the vertices? So you know what's going to happen next. Okay, we had done many of this before. So we will convert this to standard form. So this is how we begin. We factor out 6 from 6x squared plus 72x. And then this is where completing the square will come in. We will divide 12 by 2 and then we will square it. Okay? 6 squared. And then we will add 6 times 36 to 270. And that is equal to 486. We will divide this by 486, okay? 6 over 486 will give you 1 over 81. Okay, so 6 is a common factor. And then 81 divided by 486 will give you 1 over 6. 81 is a common factor. And so our equation now is in standard form. It's easy now to tell what is the center. The center is -6, 0. How about the principal axis? Well, first, what is the orientation of your transverse axis? Is it vertical or is it horizontal? We will pay attention to the term that appears after subtraction. It's y squared, which means our principal axis is horizontal, okay? It is horizontal. And you know that the principal axis passes through the center. So you know that the principal axis is the line y is equal to 0. How about the vertices? So the vertices, the foci, and the center, they are all collinear, okay? But from your standard equation, which denominator will help you find the vertex? Well, it's a squared, okay? And the denominator that appears before subtraction, that is always your a squared. A squared is equal to 81. A is equal to plus or minus 9. Okay, in my previous lessons, I was only taking the positive square root of a squared. Okay. Well, that is fine. That is fine. Okay. But, okay, we can also write it as a is equal to plus or minus 9. And so a now is like the directed distance of the vertex from the center. When you add 9, when a is equal to 9, then one vertex is to the right of your center. When a is equal to -9, then one vertex is to the left of your center. Okay? So a is equal to plus or minus 9. So what now are the coordinates of your two vertices? You know what? This can be confusing, which is why I advise you to do this. You draw the principal axis, you draw or you locate the center. Our center has coordinates -6, 0. So the vertices are collinear with the center. So that means the y coordinate of your vertices is 0. So we will pay attention only to the x coordinates. So one vertex is, you will add -9, or you will subtract 9, okay, or you will walk 9 steps to the left. And so one vertex is going to be this. It has coordinates -15, 0. And then you will walk 9 steps again, but to the right of your center. And so the coordinates is going to be this one, okay? -6 plus 9 is 3.